Okay, property of equations. Before we start writing the formal definitions, I'm going to go over this on the board really quick just so you get the concept. Let's say you have an equation like x minus 7 equals 14. In order to solve this equation, you would add 7 to both sides. Today we're going to be naming that addition property of equality. I know you've probably seen it, so just abbreviating, addition property of equality. So addition property of equality means that you can add the same value to both sides of the equation and the equation would still be true, so this would be x equals 21. So for example, if you have an equation like 2x equals 14, is that somebody at the door? Oh, she went to the restroom. If you have 2x equals 14, in order to solve this, you would have to divide both sides by 2. And all we're doing today is saying, okay, that's division property of equality. Whatever you do to one side of the equation, you have to do to the other. If you divide on one side, you have to divide by the same value on the other, and the equation will still be equal. That's essentially what we're doing today. So, learning a new format. We're learning the proof format that will eventually apply to geometry, but the basics of it's pretty simple. So, properties of equality, starting here. Filling in this chart, we have addition property of equality, and what that means is if A equals B, then A plus C equals B plus C. So you can add the same value to both sides, and you will get an equation that is true or accurate. I'll grab my notes from before. Where's my... Okay, what the heck? This is lame. One even. Okay, so subtraction property of equality is essentially the same thing. If A equals B, can you see this color pen, or is it better when I write in black?
No, we can see it.
You can see it? Okay. If A equals B, then A minus C equals B minus C. You can subtract the same value from both sides and the equation is still true. Multiplication property of equality, as you may guess, A equals B, so therefore A times C equals B times C. Division property of equality, if A equals B, then A divided by a value, call it C, equals B divided by the same value. Then next we have distributive property. Again, going to the board. Distributive property, you've seen quite a lot. You normally see it like this, 2 times like x plus 6. And then you use the distributive property, you would do 2 times x and 2 times 6. 2 times x plus 2 times 6. A lot of times we don't write out this step, we just write it as 2x plus 12, and we kind of do that math in our head, but that's distributive property. Distributive property can also be used backwards, so if you're given 2x plus 12, you could factor out a 2 and say this is, divide this by 2 to get x, and divide this by 2 to get 6, and using it backwards is also distributive property as well. So distributive property, if A times B plus C, then A times B plus C is A times B plus A times C. Substitution property, if A equals B, then A may be substituted for B. And we'll get to examples of that here in a few minutes as well. Reflexive property, this is probably the easiest one, and almost like silly that we have to write this down. But reflexive property is for any real number A equals A. A equals itself. And then symmetric property, this is A equals B, then B equals A. Kind of common sense there, but that's called symmetric. And last but not least, transitive. Transitive you will see a lot in geometry. I can guarantee you transitive will be on any assessment you take for geometry as well. Transitive is this. If A equals B and B equals C, then A must also equal C. For some of you, that might just make sense. If it doesn't just make sense, let's see. Okay, here's an example. If Zara is the same height as Caroline, got that? Zara is the same height as Caroline, and I tell you that Caroline is the same height as Kirsten over here, so Caroline's the same height as Kirsten, then Zara must also be the same height as Kirsten. That's the transitive property. Do you need me to repeat that? So if Zara is the same height as Caroline, that's a fact, well, in our situation, and Caroline's the same height as Kirsten, then Zara must also be the same height as Kirsten. That's the transitive property, and it comes up time and time again in geometry, and we'll see it more throughout this chapter as well. These examples down here, I'm going to go through just like one of them, but honestly, I think we'll get more value out of the next page. So here it says given 6x plus 2 equals 12, and the conclusion is 6x equals 10. What did they do to get to this conclusion? Well, they subtracted 2 from both sides, so this would be subtraction property of equality. And that's what these examples are about, but I don't know if they're worth the time. Some of them are a little bit confusing, so in pencil, I'm just going to cross these out for now. So cross out the bottom part, and we're going to move on to the side, the other side. Okay, over here, we're going to name that property. We have all these situations and these properties up here. These properties repeat themselves, so as you use them, don't cross them out because they get used more than once. Also, it has a blank where you can put in a letter, but honestly, I'd rather you write out the property just so you can learn them as we're doing this. So we're not going to just put in letters, we're going to just write out the property that we see. This one says if k equals 3, then 3 equals k. If you look over at the chart, all the properties are over here. That was symmetric property. If a equals b, then b equals a. So this here is symmetric property. And you can abbreviate property a little bit. Number 2, we have 2x equals 14, then x equals 7. Well, what did they do to get x equals 7? They would have to divide both sides by 2. So therefore, this is division property of equality if we want to be technical. Next, number 3, 4 equals 4. That was reflexive property. Number 4, we have this expression here, negative 5x minus 1 equals negative 11. Then negative 5x equals negative 10. So what did they do to get from this one to this one? They added 1 to both sides, so that would be addition property. Then next, we have 10a equals 2b, 2b equals c, then 10a equals c. This is the Zara equals Caroline, Caroline equals Kirsten, so Zara equals Kirsten. So this would be transitive. Next one, can you recognize that one? Distributive, perfect. And next, 6y equals 24, then 6y minus 3 equals 24 minus 3. They're subtracting the same thing from both sides, so that would be subtraction property. Number 8. This is the one I didn't give you much of an example on the other page, it says 10x plus w equals 41. Then they tell you that w equals 1. And in this here, they had plugged in 1 for w right here. Good job. Substitution. Number 9. To go from here to here, you would have to multiply both sides by 2. So therefore, multiplication property. And here, can you recognize this one? So number 10, what do you think? Perfect, it's transitive. And next, 7m equals 35, then 7m plus 4, 35 plus 4. They're adding 4 to both sides, so that would be addition property. Number 12, negative 2x equals 18, then 18 equals negative 2x. That is symmetric property. Given 3x squared plus 1, if x equals 5, then they plug in the 5. So when they plug in the number for another one, that is substitution. And 14, m equals negative 2, then 8m equals negative 6. So in order to get this expression or equation, they would have to multiply both sides by 8. So this would be multiplication property. Multiplication property. Then 15, do you remember what that one is? Not symmetric, what is it? Reflexive, good job. And last but not least, what is that one? Perfect. Okay, before you turn your page, there's one more I wanted to show you. In the textbook, sometimes you'll have situations where you have like 2x plus 7 plus 3x equals, I don't know, maybe 100. And then the next step is to simplify this. So let's say you simplify it to 5x plus 7 equals 100. You still need a reason for that, and we would call that combining like terms or simplifying it. The way the textbook labels that is substitution. So just keep that in mind. If you see a problem where they simplify like that, look for substitution because that's what they're looking for. Why do they call it substitution? I don't know, maybe I should look that up. And then there's, while we're here, while I'm talking about things that you need to know that show up on the homework sometimes. Another one is, and this we kind of touched on yesterday, so I'm on the bottom of the page, just putting in like side note, PS, like literally, PS. Segment PS is congruent to segment WX. So then, therefore, then PS equals WX's length. Like, if PS is congruent to WX, then the length of PS is equal to WX, and that is because the definition of congruent segments. So if two segments are congruent, then they have the same length. We might touch on that tomorrow, but it is one of the homework problems that might come up, so I wanted to mention that. Okay, next page. Flip. Next. Okay, now we're going to get into actual proofs. Proofs are most of the time set up in a chart like this. We will see examples where we have paragraph proofs or even flowchart proofs, but for today we're focusing on just these charts. It's called a two-column proof. You have two columns. one column is the statements and the other one is the reasons. So on the left side, we list the statements. And on the right side, we list the reasons. Oh, I should zoom in. Okay, statements and reasons. And again, I'm just kind of going over plays. Until we practice it, you're not going to really understand the play. So just going over what we need to know. Then what can be used as reasons? Well, postulates, properties, theorems, and definitions. Now, we learned some postulates yesterday. We've learned some properties, maybe a few theorems here and there. We've also learned some definitions, but these things will build as you go through geometry. So as we go through geometry, every chapter we're going to have practice on proofs that apply to whatever we're learning in that chapter. But that's kind of, don't think about the bigger picture right now. Just want you to focus on this. I'm actually going to have you we're going to start practicing. We're going to do all these, but we're going to start practicing on this side over here. So just move your paper over to the other side, and then we'll work backwards. Okay, this is a 2-column proof. Why is it a 2-column proof? Because, let me find my highlighter. There it is. Okay, here's the 2 columns. We have statements and reasons, and then this divider right here. These are statements, reasons. On this side, we're going to be like solving, and then this side is the reasons that we'll get to in a second. First step when you set up a proof would be to make the 2 columns, statements and reasons. Next step would be to write your given. So here it says given, right here. We're going to write right here, 3x plus 1 equals negative 14. And the reason we are writing that right there is because it is the given. That is step 1. Easy points for that. So sometimes when you do these, it'll be like multiple parts and you can get partial credit. This is the easiest one you can get partial credit on. Okay, now what? We have to prove that x equals negative 5. What would we do first to solve this equation? We would subtract 1 from both sides. So right here, if we subtracted 1 from both sides, we'd get 3x equals negative 15. And the reason is subtraction property. Next step would be, what would we do? Divide, perfect. Divide both sides by 3. So we'd get x equals negative 5. And the reason, division property of equality. And then we're done. Then we repeat for the next one. So step 1, fill in your given, which is 2 times x minus 9 equals negative 10. Our reason, that is what's given. Next step in solving it, what would we do? Distribute, yes. So we're going to multiply 2 times x minus 18 equals negative 10. And the reason, distributive property. Next step would be to add 18 to both sides. So I'd get 2x equals 8. If you needed to work out the steps on the side, you're totally able to do that. That's up to you. So we'd add 18 to both sides, so that's addition property. Not it. And then last step will be divide both sides by 2. X equals 4, which would be division property. And some of you are looking at me like you've been done with that problem. Good job. Next, I kind of like highlighting. It looks pretty on the paper. So next, we have another chart again. Statements and reasons are given. Write that first. Dominic, who's just coming in, is like, what is this? It's not that bad, actually. M over -3 plus 10 equals -1. Reason, that's what's given. Okay, first step in solving this would be subtract 10 for both sides. So that would be subtraction property. And we'd get m over -3 equals -11. Then multiply both sides by -3. That would be multiplication property. So we get m equals 33. And that's what I needed to prove right here. So I'm done.
So we're doing like algebra?
Yes. Well, we're doing proofs, but we're starting practicing it with algebra. Next, number 4. Make your chart. Oh, I should use blue. Keep it consistent. And then put in your given, which is 5y minus 1 over 2 equals 7. And the reason, that is what's given. And we're trying to prove that y equals 3. Step 1, we'd have to multiply both sides by 2. So multiplication property. So I get 5y minus 1 equals 14. Then add 1 to both sides, addition property. 5y equals 15. And last step, division property. Y equals 3. And we're done. Okay, we're going to go back and do the other 4 that we skipped. Okay, so now we're going to do these 4. These 4 are filled in even more than these here. Sometimes they solve it a little bit different than maybe you would solve it yourself, like maybe a different order. But whatever they did, just write a reason why they did that. So starting with number 1, they already put in the given for us, 4x minus 1 equals 27, given. Then the next step they did to get to the next part was they added 1 to both sides here. So that would be addition property. And then divided by 4 on both sides, so division property. Number 2, if you want to work ahead of me, you are more than welcome to. To get from the given to the second step, they subtracted 2 from both sides, so that's subtraction property. Then they had to multiply both sides by -6, multiplication property. Number 3. Again, cool. I see a lot of you trying to work through it on your own and just checking back to see if you got it right. It'll be distributive. And subtract 27, so subtraction property. Then divide by -18.
Do you want us to put property after every one, or could we just put like division?
I don't know. It's up to again.
Okay.
Then for the next one, this is the one that I may have solved a little bit differently. Let's see. they subtracted 6x from both sides, so that's subtraction property. Then they added 17 to both sides, addition property. Then divided by 2, so division property. And last but not least, they just changed the order of that. So 12 equals x equals 12. That is symmetric property. And that's it. That's the lesson, y'all. Pretty easy? Cool. That's the idea. Okay, so for the rest of class, you're going to use a computer to do homework 2-6. When you finish homework 2-6, jump on Khan Academy. If and when you have all 10 Khan Academy done and your homework done, then you can ask to get your phone. Cool. Okay. Ready, set, break. Yes, you may.